section 2.728. Hi, Anna. We are on 2.7. We're learning precision and accuracy today. All right, so here's the deal. I'm going to put this in like really silly, easy terms for you, okay? A lot of people use the words precision and accuracy to represent the same thing, but they have two different meanings, okay? So here's what precision means. Ready? Precision means consistent. Right? Do you know what consistent means? Consistent means like the same, right? Like doing the same thing over and over again. Consistent. Accurate means good or correct, right? Consistent and good. For example, they are not the same thing because you can be consistent, but you can be consistently bad. True? Like I am consistently bad at serving a volleyball. Okay? I just don't have the upper body strength for it. I don't know why. Okay? Consistent, good. They are not the same thing, all right? So every time you see precision, think consistent. Every time you see the word accurate, think good. Okay? All right, so let's talk about here. I'm going to go down to this target, and then I'm going to come back up to the ruler, okay? So if we look at this target, I see this first one. That is pretty darn good, right? And we're pretty darn consistent, right? So accurate, it is good, and it's consistent. So it is both accurate and precise. True? Accurate, precise. That first one is both accurate and precise, okay? The second one, it's pretty accurate, but those are more spread apart, so I'm not as consistent as I was before. True? Okay? So it's not very precise. It's not consistent. Not. But it is pretty good. Like I would be very happy with that, right? I would be pretty happy with that, okay? Now this one is somebody who's very consistent, but they are not very good, right? Consistent, but not good. True? Like I would still be happy with that. Like I'm all right. Like I'm at least hitting the target, but you know, whatever. Okay? It's consistent, but it's not real great. It's not in the middle. Okay? And then this one is neither. Not good, not consistent. Got it? Okay? Not good, not consistent. Make sense? Okay. I'm going to come back up to this one here in just a second, but let's go and do example 1, and then we'll come back up, okay? All right. This guy, we've got like the horseshoes, okay? This top one, is it precise? Is it accurate? Is it consistent? Is it good?
If you're not, well, kind of. One horseshoe isn't on it.
I think, though, even if it's not going around it, if it's like touching it, I think it still counts. Does that make sense? So you're talking about this one?
Yeah.
There's 3
Yeah?
out of the 4 that's in.
Yeah, like I would say that's pretty darn accurate though. So I'm going to say accurate and precise. A and P. Accurate and precise. Both accurate and precise, okay? Let's skip over to the right side. He is what?
Precise, not accurate.
He's precise and not accurate, okay?
Put like precise.
You can put exactly what I'm putting. I am totally lazy, and you can be lazy as well.
Well, I like
Totally
to
fine.
find it out.
Okay, fine.
Well, thank
Okay? This one,
Accurate, not precise.
accurate, not precise. Okay? I mean, like, they're not as consistent, but they're all kind of around the same area. And this one is
Not precise or accurate.
not precise and not accurate. Okay? Do we see the difference between the two? Consistent, close together, accurate, like in the right spot, right? Okay? All right, let's talk about what goes into making things precise and not precise, okay? So I'm going to go back up to where this target guy is, and let's look at these 3 lines, all right? So these 3 lines, the green one, the blue one, the red one, this is measured in centimeters. All of those lines would be measured at 8 centimeters, true? They would all be there, right? But if I were to instead, most centimeters also have millimeters in there. How many millimeters are in a centimeter, by the way? 10. 2, 3, 4, 5, 6, 7, 8, 9, 10, right? If I do that, and I do one more increment, and I'm going in millimeters now rather than centimeters, or I'm going decimals of a centimeter, okay? The green one would probably be like 8.5 centimeters, I would guess. The red one would be like maybe 8.2 centimeters, okay? And this guy, the blue one, would maybe be like 7.8 centimeters. I'm trying to like eyeball it, right? Okay? These are going to be more precise of measurements than just 8 centimeters for all. Does that make sense? Okay, if I go to the next decimal over, it's going to give me a more precise measurement. Okay? So what's the rule on precision as far as measurements go? You are more precise if you are doing smaller increments, right? Smaller increments equals more precise. Okay, I'm going to have a better measurement if I'm going to be more precise if I'm going down to the nearest 0.1 centimeter rather than the nearest centimeter, okay? Because these all represent 8 centimeters, but they're not all the same, right? Okay, it would be better to measure to the nearest millimeter, okay? That would give me a more precise measurement. Precision is to the smallest increments possible. Got it? Okay, let's talk about what makes accuracy then. Okay? Accuracy has to do with error. So like how far is my measurement off from what it actually is supposed to be, okay? So when we're doing error, we take our actual measurement, I subtract the expected measurement, and then I do the absolute value. So it's basically the difference between the two. I have something that is 10 grams. I know that it's 10 grams, right? And I'm going to put it on 3 different scales. One of them is a spring scale. Do you know what a spring scale is?
It's like a thingy and it goes.
Like you hold it and then it like pulls the spring down and it like measures how heavy something is. People have those for like their luggage. If somebody has a baby at home, like they wrap them up in a blanket and they'll hold them on a spring scale and they'll measure them that way, right? Okay. Oh, hey, there you go. Yeah. Then there's a lab scale, and then we have a food scale, right? So some people might have a food scale in their kitchens, and then there's a lab scale, okay? Now, we know that our object is 10 grams. My spring scale is measuring it to be 9.86. And all I'm doing is subtracting the two and finding the absolute value. So if it ended up coming out as negative, we're going to do the positive, right? So this guy is 0.14 grams off. Does that make sense? It's how far it is off from what the actual is, okay? How far is the second one off? The slab scale, 0.08. 0.08 off. The next one, if I subtract the 10.3, that would be negative 0.3, but the absolute value would be positive 0.3, right? So which one is the best one? Which one is off by the least amount? What? The lab scale is off by less. This one is the most what? Accurate. Accurate means that it is the closest to what the actual should be, right? Like we're hitting the target, okay? Most accurate. So that has to deal with that. Precision is what units you measure in. I want to be the smallest increment of units to be the most precise. But accuracy has to deal with like how close am I to the actual amount. Got it? A lot of times with more precision becomes more accuracy, but not always.
Grades 9 through 12, if you have not yet voted for homecoming royalty, you need to do that by the end of lunch today. Voting will end after lunch today. A reminder that there will be NHS in the gym with games the last 10 minutes of lunch.
With
Anyone who
James?
dressed up today,
Who's
please
James?
come to the office at this time for a
Oh,
picture.
I heard James. Okay, hold on. Wait. Oh, you gotta go take a picture? Boo. All right. Okay, we'll finish this tomorrow. No homework.
Yay.
Bye. Okay, Anna, we're gonna be all sorts of messed up now because like we had shortened periods. So yeah, we'll just make do.
For you though, no homework.
I gotta
Yeah. All right. Bye, Anna.